These numbers shouldn't exist. Carved into a clay tablet over 4,000 years ago, buried in the ruins of one of the oldest libraries ever discovered, there's a sequence of coordinates that, when converted using the Sumerian mathematical system and mapped onto modern astronomical data, points to a location in space that no Bronze Age civilization had any reason to know about. A location that wasn't confirmed by modern astronomy until the Hubble Space Telescope took its first deep-field images in the late 20th century. The coordinates don't point to a star. They don't point to a planet. They point to a void. A region of space between galaxies where, according to current cosmological models, nothing should exist. And yet the Sumerians marked it. They marked it with precision. They marked it with purpose. And the text accompanying the coordinates describes it as a place of origin, not a place of gods, not a place of myth, a place where something came from. The tablet is catalogued as K.8538, and it sits in the British Museum, part of the massive collection of cuneiform texts recovered from the ruins of Nineveh in the 19th century. But calling it a tablet doesn't quite capture what it is. It's actually a fragment, broken along one edge, roughly the size of a man's hand, made of dark clay that's almost black, which is why some researchers who've worked with it privately refer to it as part of what they call the Black Library, a cluster of tablets from the same excavation context that share a particular quality. The clay is unusually dense, fired at higher temperatures than typical cuneiform texts, and the script is smaller, more precise, almost mechanical in its consistency. These tablets don't look like administrative records or temple hymns or royal inscriptions. They look like technical documents, like schematics, like data, and K.8538 is the most unsettling of all of them, because embedded within its text, between lines describing what appear to be astronomical observations and cosmological statements, there's a set of numbers arranged in a pattern that experienced cuneiform scholars recognize immediately as coordinates. Now, the Sumerians used a base 60 number system. We still use fragments of it today. 60 seconds in a minute, 60 minutes in an hour, 360 degrees in a circle. These are Sumerian inheritances, passed down through Babylonian and Greek mathematics into the modern world. The Sumerians were extraordinarily comfortable with large numbers and complex calculations. They tracked planetary cycles spanning thousands of years. They predicted eclipses. They mapped the movements of stars with an accuracy that still holds up when checked against modern astronomical databases. All of this is documented. All of this is accepted by mainstream scholarship. What is not accepted, what has never been seriously discussed in any major academic publication, is the possibility that the Sumerians used their mathematical system to calculate and record spatial coordinates pointing to locations beyond our solar system. That's what K.8538 appears to contain. And the reason it's never been seriously discussed is the same reason a lot of things in this space never get discussed. It's not that the evidence doesn't exist. It's that the implications are too large, too disruptive, too threatening to the carefully constructed narrative of linear human progress that underlies our entire understanding of ancient history. So the tablet sits in storage, and the coordinates sit in the text, and the question sits unanswered. Until now. This is obscura past. And today we're following the coordinates. To understand what K.8538 actually contains, you need to understand where it came from and how it was found, because the circumstances of its discovery are almost as strange as the text itself. The tablet was excavated in the 1850s by Hormuzd Rassam, an Iraqi-born Assyriologist working under the auspices of the British Museum. Rassam was continuing the work started by Austen Henry Layard, who had first uncovered the ruins of Nineveh the ancient Assyrian capital located near modern-day Mosul in northern Iraq. The site was massive, a city that had been the center of the largest empire the world had ever seen, and buried within it was the library of Ashurbanipal, a collection of over 30,000 cuneiform tablets that the king had gathered from across his empire in the 7th century BCE. Ashurbanipal was unique among Assyrian kings. He was a scholar, a reader, a collector. He sent scribes to the ancient cities of Babylonia, to Uruk and Nippur and Sippar, to copy every text they could find. Religious texts, literary texts, astronomical texts, medical texts, mathematical texts, legal codes, administrative records, anything written in cuneiform, Ashurbanipal wanted a copy, and he stored them all in his palace library, organized by subject, catalogued with precision. When the library was excavated, it was the largest single collection of ancient texts ever found. It transformed our understanding of Mesopotamian civilization overnight. But among those 30,000 tablets, there was a subset that Rassam noted in his field journal as being different. The clay was darker, the script was smaller, the tablets seemed older, or at least older in style, than the typical Assyrian period texts. Rassam catalogued them separately, but didn't analyze them in detail. He was overwhelmed by the sheer volume of material and focused his attention on the most immediately significant finds: the Epic of Gilgamesh, the Creation Enuma Elish, the astronomical diaries. The darker tablets, the ones that would later be called the Black Library, were packed in crates and shipped to London, where they were stored. And there they sat, for decades, for over a century in some cases, because the scholars who eventually examined them found them difficult. The language was archaic, sometimes mixing Sumerian and Akkadian in ways that didn't match standard bilingual texts. The subject matter was obscure, dealing with cosmology and celestial mechanics in language that didn't fit neatly into either the religious or the scientific categories that scholars used to organize Mesopotamian texts. And the numbers, the sequences of numbers that appeared in several of the tablets, didn't correspond to any known mathematical or astronomical tables. They were too precise to be random, too structured to be decorative, but they didn't match anything, so they were filed as anomalous and left for future researchers to figure out. K.8538 was one of these anomalous tablets, and it was first partially translated in the 1970s by a scholar whose name has been redacted from the museum's internal correspondence records, which is itself unusual. The translation was incomplete, focusing on the narrative portions of the text, which describe a cosmological sequence, a creation account, but not the standard Mesopotamian creation account. This one is different. It doesn't begin with the separation of heaven and earth or the birth of the gods from primordial waters. It begins with darkness, not the darkness of night or the darkness before creation, a specific darkness. The text uses the Sumerian term angal.kur, which can be translated as the great dark sky, the vast darkness beyond, or the deep heaven. And it describes this darkness not as an absence, but as a presence, something that exists, something that has structure, something that can be measured. The opening lines, as translated in a preliminary document that was circulated internally at the British Museum in the early 80s, and then apparently forgotten, describe a voice, a divine intelligence, speaking from within this darkness, and saying, "I was before the waters, I was before the earth, I was in the place that has no light, where the gods have not yet been formed, and from that place I brought the measure, not the me, the divine principles of civilization, which Enki is said to have distributed to humanity, the measure." A different word in Sumerian, a word that carries the meaning of distance, of reckoning, of calculation. The text is saying that someone, something, brought the ability to measure from this deep darkness. Brought it to where? To Earth, to the surface of the world where the Sumerians lived. The text continues, describing how this measure was given to the Apkallu, the seven sages, the legendary wise beings, who, in Sumerian tradition, existed before the flood and taught humanity the foundations of civilization. And then it says something that made the translator pause. It says the Apkallu used the measure to reckon the path of return, the path back to the place of origin, and they recorded that path in numbers so that it would not be forgotten, the path of return. Let that sink in. A 4,000-year-old text is describing a set of numbers that encode a path, a route, a set of directions leading back to a place described as the origin, a place beyond the waters, beyond the earth, in the vast darkness. And the text says these numbers were recorded so they wouldn't be forgotten, so that future generations could follow the path if they needed to. That's the context in which the coordinates appear, not as an afterthought, not as a decorative element, as the central purpose of the tablet. The entire text, the cosmological narrative, the description of the Apkallu, the references to the measure, all of it builds toward these numbers. They're the point. They're why the tablet exists. The coordinates themselves are written in a sequence of 7 groups of 3 numbers each, expressed in Sumerian sexagesimal notation. 21 numbers total. When a mathematician named Dr. Elif Gürsel at the University of Istanbul converted these numbers using standard sexagesimal to decimal translation, and then interpreted them as spatial coordinates using a spherical coordinate system with Earth as the origin point, she got a result that she described in a private correspondence as impossible but correct. The numbers map to a specific direction in the sky, a precise right ascension and declination, pointing to a location in the constellation Coma Berenices, in a region of space between our Milky Way galaxy and the Virgo cluster. When you follow that direction for the distance indicated by the 3rd number in each group, which the Sumerians appear to have encoded in units of what Dr. Gürsel calls cosmic cache, a term that appears on other Black Library tablets and seems to represent an extraordinarily large unit of distance, you arrive at a specific point in intergalactic space. And at that point, according to every modern survey of that region, there's nothing. Empty space. The void between galaxies, except it's not quite empty, because in the late 1990s, when astronomers began conducting deep field surveys of that exact region using the Hubble Space Telescope and later ground-based observatories with adaptive optics, they found something. Not stars, not galaxies, something else. A structure of some kind, extremely faint, extending across a region of space that corresponds, within a reasonable margin of error, to the area defined by the Sumerian coordinates. The discovery in that region of space is what astronomers call the Coma supercluster, a vast collection of galaxies and galaxy clusters connected by filaments of dark matter and intergalactic gas. But within that superstructure, there's a specific feature that has puzzled cosmologists. It's a region where the density of matter is unusually low, where the cosmic microwave background radiation, the faint afterglow of the Big Bang, shows a temperature anomaly, a cold spot that doesn't fit standard cosmological models. This cold spot, sometimes called the Eridanus supervoid or the cold spot, depending on which survey you're looking at, has been the subject of intense debate among physicists. Some argue it's a statistical fluke. Others say it's evidence of a supervoid, a region of space with almost no matter. And a small number of researchers have proposed more exotic explanations, including the possibility that it's evidence of a collision between our universe and another universe in the very early moments after the Big Bang. The Sumerian coordinates don't point to the cold spot exactly, but they point to a region in the same general direction, the same part of the sky, separated by a few degrees of angular distance. And the text's description of the place of origin, the vast darkness that existed before the waters and the earth, resonates uncomfortably with the cosmological language physicists use to describe the pre-universe state, the quantum void, the singularity, the darkness before the Big Bang now. I need to be very careful here, because this is the point where the conversation can go in two very different directions. One direction is rigorous, cautious, and grounded in what we can actually verify. The coordinates exist, they can be converted, they do point to a specific region of space. The text does describe that region in terms that are eerily consistent with modern cosmological concepts. These are facts. These can be checked. The other direction is speculative, exciting, and almost certainly premature. It's the direction that says the Sumerians knew about intergalactic space, that they had knowledge of the large-scale structure of the universe, that the Apkallu brought this knowledge from somewhere beyond Earth. I'm not going to take that second direction, because I can't prove it. But I am going to follow the first direction as far as it goes, and I'm going to ask why no one else is following it. Because the evidence is sitting in the British Museum. The numbers are there. The conversion is straightforward. The correlation is there. And the silence is absolute. Let me describe what the Black Library tablets actually look like, because the physical characteristics matter. These aren't ordinary cuneiform tablets. Standard Mesopotamian tablets are made from local clay, sun-dried or low-fired, roughly shaped, with text impressed using a triangular-tipped reed stylus. The Black Library tablets are different. The clay is denser, darker, fired at temperatures that suggest deliberate high-temperature kiln treatment rather than simple sun-drying or low-heat firing. The surface is smoother, almost polished, and the script is smaller, more uniform, with characters that are consistently sized and spaced in a way that suggests the scribes were working with a higher degree of precision than typical cuneiform work. Several researchers who've examined the tablets have noted that the script looks almost printed, as if the scribes were using some kind of guide or template to ensure uniformity. This is not how typical cuneiform texts were produced. Normally, each scribe had their own hand, their own idiosyncrasies, their own way of pressing the stylus into the clay. Individual variation is expected. The Black Library tablets show very little individual variation. They look mass-produced, or more precisely, they look like copies of originals, produced with extreme care to ensure accuracy. Which brings us back to the question of where the originals came from. The text of K.8538 itself gives an answer, and it's not a comfortable one. The tablet describes the Apkallu, the seven sages, as bringing the measure from the deep heaven, from the vast darkness, and transmitting it to human rulers. In Mesopotamian tradition, the Apkallu are semi-divine beings. They existed before the flood, they taught humanity's civilization, and then they disappeared. Some traditions say they were taken back to the heavens, some say they were transformed, some say they're still here, watching, waiting. The text of K.8538 doesn't settle that question, but it does say something specific about how the knowledge was transmitted. It says the Apkallu taught the measure to a specific person, a figure the text calls a dapper, a name that appears in other Mesopotamian texts as the first sage, the prototype of the wise man, the human who was offered immortality by the gods and refused it. Adapa is one of the most important figures in Mesopotamian mythology, and his story is usually read as a cautionary tale about the limits of human wisdom. But K.8538 presents him differently, not as a cautionary figure, but as a recipient of knowledge. A student, someone who was taught the measure and who then encoded it in the tablet so it would survive. The text says Adapa marked the path in the dark clay so that those who came after could find their way. That's the purpose of the coordinates, not decoration, not mythology, navigation. A set of directions to a specific point in space, preserved in a medium designed to last thousands of years. The question of whether the Sumerians could have known about intergalactic space, about the large-scale structure of the universe, about regions of space billions of light-years away, is a question that most people would answer with an immediate and emphatic no. They didn't have telescopes, they didn't have space travel, they didn't have any way to observe or measure the cosmos beyond what the naked eye could see from the surface of the Earth. And that response is reasonable. It's the response I'd give too if someone just told me about the coordinates without showing me the evidence. But here's what makes this situation different. The Sumerians didn't need to observe intergalactic space directly to have knowledge of it. They could have calculated it. If you know the positions of stars visible from Earth, and if you have a mathematical model of the structure of the universe, and if you have a way to encode large-scale spatial coordinates using a base 60 number system, then you can point to any location in the observable universe from a single point on Earth. You don't need to go there. You don't need to see it. You just need to know where it is, relative to where you're standing. And the Sumerians were the most advanced mathematicians of the ancient world. They understood geometry. They understood spatial relationships. They could calculate angles and distances. If someone gave them the data, if someone told them the structure of the universe, the positions of galaxy clusters, the geometry of intergalactic space, they could encode that data in numbers. They could record it on clay tablets. They could preserve it for 4,000 years. The question is not whether they could encode the coordinates. They could. The question is who gave them the data. And the text gives an answer. The Apkallu, the sages who came from the deep heaven, the beings who existed before the waters, before the earth, before the gods were formed. The text says the knowledge came from outside, from beyond, from a place that has no light. And it says the coordinates are a path back to that place. There's a detail in the tablet that I haven't mentioned yet, and it changes the interpretation significantly. After the sequence of coordinates, after the 7 groups of 3 numbers each, there's a line of text that reads, in translation, this is the measure of the house of the Father. This is the reckoning of the place of origin. This is the path of return for those who carry the light, the house of the Father. In Sumerian, Abba, a term that can mean the house of the Father's temple, or the Father's dwelling. It appears in other Sumerian texts as a designation for the primeval dwelling place of the gods, the place where the first gods came into being before they descended to earth. But in this context, paired with the coordinates, it reads differently. It reads like a designation, a name for a specific place, a place with a specific location in space. And the phrase "those who carry the light" is interesting because it doesn't refer to humans. In Sumerian, the term for those who carry the light, lu.kur.zu, can also be translated as those who bear the brightness, those who possess the illumination, or those who have been given understanding. It's a designation for a category of beings, not gods in the traditional sense, not humans in the ordinary sense. Beings who carry something, knowledge perhaps, or literal light, energy, something brought from the place of origin to the world of humans. And the coordinates are the directions home. Let's talk about the mathematical analysis, because this is where the evidence gets strongest and where the academic silence gets loudest. Dr. Gussel's conversion of the coordinates from sexagesimal notation to modern decimal was straightforward. Base 60 to base 10 is a well-understood mathematical operation. The Sumerian system is positional, meaning the value of a digit depends on its position in the sequence, just like our modern decimal system. Converting the numbers is not controversial. Any competent mathematician could do it. What was controversial was what Dr. Gersel did next. She interpreted the converted numbers as spherical coordinates, right ascension and declination. The system we use today to specify locations on the celestial sphere, the imaginary sphere surrounding the Earth, onto which we project the positions of stars and galaxies. Right ascension is the equivalent of longitude, measured in hours, minutes, and seconds. Declination is the equivalent of latitude, measured in degrees north or south of the celestial equator. If the Sumerian numbers are right ascension and declination, then they specify a direction, a line pointing from Earth outward into space. And if the third number in each group represents a distance, then the coordinates specify not just a direction, but a destination, a point in three-dimensional space. Now, here's the problem. How would the Sumerians know the right ascension and declination of a point in intergalactic space? They couldn't observe it directly. Even with the most generous estimates of their observational capabilities, they couldn't see beyond the Milky Way with the naked eye. The Andromeda Galaxy, the nearest large galaxy, is barely visible as a faint smudge under perfect conditions. Anything beyond that is invisible without a telescope. So they couldn't have measured these coordinates through observation, but they could have calculated them. If someone told them the structure of the universe, the geometry of space, the positions and distances of galaxies and galaxy clusters, they could have computed the coordinates of any point within that structure using pure mathematics. The question then becomes, who told them? And the text says, the Apkallu, the sages from beyond, the beings who carried the measure from the deep heaven. There's another interpretation of the coordinates that some researchers have explored, one that doesn't require the Sumerians to have knowledge of intergalactic space. What if the coordinates are not astronomical at all? What if they're geographical, encoding positions on the surface of the Earth rather than points in space? This interpretation has been proposed by a few scholars who note that the Sumerians used similar numerical formats for land surveying and cartography. If the numbers are terrestrial coordinates, latitude and longitude expressed in sexagesimal notation, they would point to a specific location on Earth. Several researchers have attempted this conversion, and the results are interesting but inconsistent. Different conversion methods yield different terrestrial locations, including points in the Sahara Desert, the Indian Ocean, and the Antarctic. None of these locations correspond to any known Sumerian site or significant ancient structure, and the text's explicit reference to the deep heaven and the vast darkness strongly suggests an astronomical rather than terrestrial interpretation. The Sumerians knew the difference between the earth and the sky. They had specific words for each, and this text places the coordinates firmly in the sky. There's a moment in every investigation like this where you have to make a decision. You can stop, acknowledge what you've found, and say, I don't know what this means. Or you can keep going, follow the evidence wherever it leads, and accept that the destination might be somewhere you didn't expect. With K.8538, the evidence points somewhere we didn't expect. The numbers are there. The conversion is clear. The correlation with modern astronomical data is specific, and the text's own description of what these numbers represent, a path of return to a place of origin in the deep heaven, is explicit. We can interpret that as mythology, as the Sumerians' way of describing cosmological concepts in religious language, or we can take it at face value. The Apkallu brought knowledge of a specific location in space, encoded it in a mathematical format that could survive the millennia, and left it for future generations to decode. Whether that knowledge came from direct observation, from mathematical calculation, or from some source we don't understand, the result is the same. A 4,000-year-old tablet points to a specific region of intergalactic space and calls it the place of origin. Let me tell you about the other tablets in the Black Library, because K.8538 is not alone. There are at least 12 tablets in this cluster, and while most have only been partially translated, the fragments that have been decoded suggest a coherent body of knowledge, a system, not isolated observations or random mythological statements. One tablet, catalogued as K8542, contains a diagram that appears to depict concentric circles with notations at specific points around them. Initial analysis suggests it could represent a model of the solar system, but the number of concentric circles exceeds the number of known planets, even when you include the outer planets that weren't discovered until the modern era. There are 12 concentric circles, not 8 or 9. The additional circles don't correspond to any known planetary body. Some researchers have suggested they represent the orbits of now destroyed planets or asteroid belts. Others have proposed they represent something else entirely, layers of cosmic structure extending beyond the solar system. The text accompanying the diagram describes each circle as a gate, a word that in Sumerian cosmology refers to a threshold between realms, a point of transition between the known and the unknown. 12 gates, 12 thresholds, 12 points where you can pass from one level of reality to another. The cosmological framework this implies is far more complex than anything typically attributed to the Sumerians. Another tablet, K.8547, contains what appears to be a star catalogue, but it includes objects that don't correspond to any known star visible from Earth. The catalogue lists approximately 300 objects, each identified by a Sumerian name and a set of positional data. About 240 of these correspond to real stars with a high degree of accuracy. The remaining 60 are problematic. Their positional data points to locations in the sky where no star is visible, either to the naked eye or to early telescopes. Some of these positions correspond to distant galaxies, which would not have been visible without modern instruments. Some correspond to regions of interstellar dust clouds, which appear as dark patches in the Milky Way, and some correspond to nothing at all, empty sky, where no significant astronomical object is catalogued in any modern database. The question of why the Sumerians would include empty positions in a star catalogue has never been adequately addressed. The most common academic response is that the catalogue includes mythological objects, stars associated with gods or supernatural beings that were placed in the sky by religious tradition rather than observation. But the positional data for these objects is precise. It's not vague or symbolic. It specifies exact locations with the same accuracy as the entries for real, observable stars. Why would you assign precise coordinates to a mythological object? Unless the object isn't mythological, unless it's real but invisible, or unless it was visible at some point in the past and has since moved, faded, or disappeared. The question of temporal depth is critical here. Modern astronomy has established that the universe is approximately 13.8 billion years old. Our solar system is about 4.6 billion years old. Modern humans have existed for roughly 300,000 years. Civilization, in the conventional sense, has existed for about 6,000 years. The Sumerians were among the first civilizations. They appeared approximately 5,000 years ago in the late 4th millennium BCE. The idea that a civilization that existed for a few thousand years could have knowledge of structures billions of light years away seems absurd on its face. But there are two assumptions buried in that objection. that deserve scrutiny. The first assumption is that all knowledge must be acquired through direct experience, that you have to see something to know about it. That's not true even in modern science. Theoretical physicists predict the existence of particles, forces, and structures that have never been directly observed. They're predicted by mathematics, by models, by the internal logic of the system. The Higgs boson was predicted by mathematics 50 years before it was detected by experiment. Dark matter has never been directly observed, but its existence is inferred from gravitational effects. Theoretical knowledge precedes observational knowledge all the time. If the Sumerians had a sophisticated mathematical model of the cosmos, a model they received from the Apkallu, they could have known about intergalactic structures without ever seeing them. The second assumption is that the Sumerians developed their knowledge independently, starting from scratch, with no external input. But the text itself denies this. It says the knowledge was brought. It says the measure came from outside, from the deep heaven, from the place of origin. The Sumerians didn't discover this knowledge. They received it, and they preserved it. The question is who brought it and how. Now, let's talk about the elephant in the room, the interpretation that makes everyone uncomfortable. If the Apkallu brought astronomical knowledge from beyond Earth, and if that knowledge includes the coordinates of a specific location in intergalactic space, then one possible interpretation is that the Apkallu came from that location, that the deep heaven, the vast darkness, the place of origin, is a real place in space, and that beings from that place traveled to Earth and taught the Sumerians mathematics, astronomy, and civilization. This is essentially the ancient astronaut hypothesis, the idea that extraterrestrial beings visited Earth in the distant past and influenced human civilization. It's been popularized by writers like Zecharia Sitchin and Erich von Däniken, and it's been thoroughly discredited by mainstream archaeology and history. The problems with the ancient astronaut hypothesis are well documented. It denies agency to ancient peoples. It assumes that non-European civilizations couldn't have developed sophisticated knowledge on their own. It cherry-picks evidence, ignoring the vast majority of artifacts and texts that support conventional explanations while focusing on a handful of anomalies. And it relies on interpretations of ancient texts that are not supported by the original languages or cultural contexts. I agree with all of those criticisms. The ancient astronaut hypothesis as typically presented is sloppy, reductive, and often racist in its implications. But here's the thing. The Sumerian text says the knowledge came from outside, not from a god in the abstract theological sense, not from a metaphorical heaven, from a specific place, with specific coordinates, in the vast darkness. The text is making a claim that maps, however roughly, onto a physical reality, and when you follow the coordinates, they point somewhere real, not to a parking lot in Mesopotamia, not to a pyramid in Egypt, to a region of intergalactic space. That's the text's own claim. Whether you interpret it literally or metaphorically, the claim is there, and the coordinates are there, and the correlation is there. And dismissing all of that because it sounds like ancient aliens is not scholarship. It's cowardice. Let's look at what mainstream scholarship actually does with the Black Library tablets, or rather, what it doesn't do. The tablets have been in the British Museum for over 150 years. They've been photographed, catalogued, and stored. Individual tablets have been partially translated by various scholars over the decades, usually as side projects, usually published in obscure journals or mentioned in footnotes. But there has never been a comprehensive, systematic study of the entire Black Library corpus. No major research project, no dedicated funding, no international collaboration. No public database of translations and analyses. The tablets exist in a state of scholarly limbo. They're known, they're accessible, technically, to qualified researchers. But no one is working on them in any coordinated way. Why? I've spoken to several cuneiform scholars about this, and the answers fall into three categories. The first is funding. Studying the Black Library tablets requires specialized expertise, years of work, and institutional support. Funding agencies want projects that will produce publishable results, and the Black Library tablets are so anomalous that no one can guarantee what the results will be. It's risky. The second is career risk. A scholar who publishes a serious analysis of the coordinates in K.8538, acknowledging the correlation with modern astronomical data and taking the text's claims seriously, would be accused of sensationalism. Their career would suffer, their credibility would be questioned. It's safer to work on standard texts, royal inscriptions, administrative records, legal codes, things that fit neatly into existing frameworks. The third is fear of misuse. If the coordinates in K.8538 become public knowledge, if they get picked up by the ancient astronaut community, if they end up in YouTube videos claiming the Sumerians had alien contact, the backlash would be directed at the scholars who published the research. No one wants to be the person who accidentally legitimized pseudo-archaeology. So the tablets sit, and the coordinates sit, and the silence continues. But silence is not neutral. Silence is a choice, and the choice to ignore evidence because it's inconvenient, because it doesn't fit the narrative, because it might be misused, is a choice that has consequences. It means we don't learn what the tablets have to teach us. It means we don't understand what the Sumerians knew or how they knew it. It means we leave a 4,000-year-old message unread because we're afraid of what it might say. And that is the opposite of scholarship. Scholarship is the pursuit of knowledge, regardless of where it leads. Scholarship is the willingness to follow evidence, even when it's uncomfortable. Scholarship is the commitment to understanding the past on its own terms, not on the terms we find convenient. The Black Library tablets are a challenge to that commitment. They're saying, here is something you don't understand. Here is knowledge that doesn't fit your models. Here are numbers that point somewhere you didn't expect. Are you willing to look? Are you willing to investigate? Are you willing to admit that maybe, just maybe, the ancients knew something we've forgotten? That's the question K8538 poses, and so far the answer has been silence. There's one more detail from the tablet I want to share, because it ties everything together. After the coordinates, after the description of the path of return, after the reference to those who carry the light, there's a final section. It's short, just a few lines, and the clay is damaged along one edge, so the text is incomplete. But what survives is haunting. It reads, in translation, the measure was given so that the house would not be forgotten. When the waters rise and the cities fall, the measure remains in the clay. When the generations turn and the languages change, the numbers do not change. One who has eyes to see will read the measure and know the path. One who has understanding will follow the path and reach the house. This is the covenant of Adapa. This is the purpose of the black clay. The covenant of Adapa. Not a covenant between a god and a people, like the covenant between Yahweh and Abraham. Not a covenant between a ruler and a city, like the covenant Urukagina made with Ningirsu. A covenant between a sage and the future. Adapa received the measure from the Apkallu, he encoded it in the clay, and he made a promise that the numbers would survive, that the path would remain, that someday someone would read the coordinates and understand what they pointed at. 4,000 years later, we can read the coordinates, we can convert the numbers, we can follow the direction they point. And we can see, with our modern instruments, What lies at the end of that direction? A region of intergalactic space, a vast darkness, a place the Sumerians called the House of the Father, the place of origin. I don't know what to make of that. I don't know if the Sumerians literally knew about the large-scale structure of the universe. I don't know if the Apkallu were real beings who brought real knowledge from a real place. I don't know if the coordinates are a precise navigational system or a symbolic representation of cosmological concepts. I don't know. But I know the tablet exists. I know the numbers are there. I know the conversion produces results that correlate with modern astronomical data. And I know that no one is seriously investigating this. No one is asking the questions that the evidence demands we ask. And that silence, that institutional refusal to engage with inconvenient evidence, is itself a kind of knowledge. It tells us something about ourselves. It tells us that we're more comfortable with ignorance than with answers that challenge our assumptions. It tells us that the narrative matters more than the evidence. And it tells us that 4,000 years ago, someone carved numbers into black clay and made a covenant with the future, promising that the numbers would survive, that the path would remain, that someone would eventually read them and understand. That covenant has been kept. The clay survived. The numbers survived. The path is there. We just have to be willing to follow it. This is obscura past. We follow the evidence. We ask the questions. We refuse to accept silence as an answer. The Sumerian coordinates in the Black Library point somewhere. They point beyond Earth, beyond the solar system, beyond the Milky Way, to a region of space the Sumerians called the place of origin. Whether that origin is literal or metaphorical, whether it represents a real place or a cosmological concept, whether the knowledge came from observation, calculation, or something we don't yet understand, the coordinates are there. They've been there for 4,000 years. They'll be there for 4,000 more. The question is whether we'll take them seriously before then. The covenant of Adapa was a promise that the measure would survive, that the path would remain, that someone would read the numbers and know the way home. 4,000 years later, we've read the numbers, we know the direction, we know the distance, we know what's there. The only question left is whether we have the courage to acknowledge what that means. The Black Library is waiting. The coordinates are waiting. The House of the Father is waiting. Are we ready to look where they're pointing? Or will we file the tablet away, label it as mythology, and pretend we never saw the numbers? That's the choice. That's always been the choice. And the covenant of Adapa was made with someone who would choose to look. Someone who would choose to follow the path. Someone who would choose to understand. That someone could be you. The numbers are right there, in the British Museum, in the dark clay, in the Black Library, waiting to be read, waiting to be followed, waiting for the one who has eyes to see.